Hey guys, welcome back to MROB. Today's lesson is going to be on area, but before I begin, I wanted to start with something a little fun to do, like a game. Kind of like 2 truths and 1 lie. Except it's going to be 2 of these things I've done before coronavirus, and 1 of these things I've done because of the coronavirus. So let's see if you can guess. I had to write things down because that's how I remember stuff. I write stuff down. So, installing a cabinet. Is that before, or is that because? Cutting my own hair. Is that before, or is that because of coronavirus? And the last one, putting together a puzzle. Think about me. Which one do you think I'm done before coronavirus, and which one I've done afterwards? So, cutting my own hair. You know in the movies, when you get to the climax and the female character is like changing her ways, she cuts her own hair, and then after that, nobody ever messes with her again. I cut my own hair before. Installing a cabinet, carpentry, measure twice, cut once. You know, do your problem on the calculator, not on the calculator, check your answers. I feel like that and math go together. I did that before. But sitting down long enough to do a puzzle is definitely something I achieved during the coronavirus era. Want to see it? There it is, 1,000 pieces. Of course I had some help. All right, now let's get back to the lesson. So we're doing area, and I'm going to go over the shapes. And I'm going to start with a triangle. Scratch that. I'm going to start with a parallelogram. So in a parallelogram, you have opposite sides that are equal and parallel. Parallel means that the 2 lines never touch each other. So these are parallel. This shape, more specifically, which has right angles, is a rectangle. But, and if you remember from a rectangular formula, we're going to call our sides base and height. Base and height are always perpendicular to each other. That's a very important thing to know about base and height. And they have to be perpendicular to each other. So if you take a rectangle and you slant it, it's still a parallelogram, but it doesn't have the right angles, so it's not a rectangle. And the thing is, in base and height have to be perpendicular to each other. Now the height is not actually a side. It's an imaginary line over here that's perpendicular to the ground, and that's important to remember. The height does not always have to be a side of the parallelogram. Okay, so now if you were to take your rectangle that we had, and you were to cut it in half, you would get what shape? A triangle. Now if I'm cutting it in half, I'm going to get half of the rectangle, which I forgot to write down. The rectangle formula, or parallelogram formula. So area of a parallelogram is base times height, and if I cut it in half, I get a triangle, which is why the triangle formula is half base times height. And then the other shape we're going to talk about today is a trapezoid, which I'll do on the sheet. And I want you to know that besides this video, there are other really great videos that can do things with technology that I'm not able to do right now. So I want to make sure you watch the other videos on MROB's playlist. So I'm going to go back to the triangle because parallelograms are easier than triangles. Okay, I'm going to take these 2 Legos. I'm going to use blue for my base and yellow for my height. Base and height are always perpendicular to each other. So what particular kind of triangle is this one? That's right, this is a right triangle. Not every triangle is a right triangle. And the important thing I want you to know is that the base does not always have to be on the bottom. Okay, a common misperception is that my base is always on the bottom. My base is always perpendicular to my height. If I took my board and turned this triangle, I didn't change the triangle, I didn't change the area, I didn't change the base or the height. Or I can take it and if I put it upside down, now the base is on top. So just an FYI, base does not have to be in the bottom, but base and height do have to be perpendicular. Now, remember what I said before with parallelograms. The height doesn't actually have to be one of the sides. When it's a right triangle, it is one of the sides. So I'm going to show you two other ways this triangle could look, but still have the same base and height, which would mean they would still have the same area, because the area of a triangle is 1/2 the base times the height. I still had the parallelogram one up. So see these 2 points right here? I made them bigger. Points are, the corner of the triangle is called a vertex. Another, when I have more than one vertex, because there are definitely 3 of them, it's called vertices. They are the same word. One is singular and one is plural. There are 3 vertices in a triangle. So I'm going to keep these 2 points here, and I'm going to take this point and stretch it out over here. So now this point is here. My height is the same, my base is the same, but my triangle is really stretchy, and this triangle is more than 90 degrees, which we'll go over in another section, which would make it obtuse, and it would also make it scalene. I don't have any sides the same. When I have sides the same, I put dash marks on them. So besides the height being part of the triangle and the height being outside the triangle, I could also have the height inside the triangle. So if I was to take this point attached to the top of my yellow brick and move it in here, I could make a different triangle with the same area. This one's more like a what kind of triangle? Let's say these 2 sides are the same. This would be an isosceles triangle. The height is, again, an imaginary line perpendicular to the base on the inside. And that's important. So I'm going to put these examples on the paper, and I'm going to get going in the packet now. The packet that you either get from Google Classroom by printing it out on the PDF, writing it on notebook paper, doing it digitally with Cami, or picking it up from the school. If you pick it up from the school, I attach the mega notes to the front. Here's all my area formulas. Don't forget perimeter is the distance around. Distance around is perimeter, which is often confused with area, which is space inside. So anyways, these are the mega notes. And then there's volume and some more triangle stuff like the classifications. We're going to get to angles later. These notes are going to cover 2 or 3 days. Pay attention to what it says on Google Classroom. So right now I am on this page, and we're going to fill in the 3 triangles we just went over. Okay, I'm going to do all the examples on this page 1 and then on page 2. And again, that'll cover 2 or 3 lessons, but I want you to watch the other videos I put on there too. So you see that there is 3 exterior sides to this. It is a triangle. It has lots of different numbers. You're going to want to do the area. Area is 1/2 the base times the height. The base and the height, remember, have to be perpendicular. Very important. Perpendicular means that the 2 lines come together at a right angle. Perpendicular. Make sure you write that down. This is a right angle. Whenever you see that box, it's a right angle. If you don't see the box, do not assume it's 90 degrees. Could be 89 degrees. Could be 91 degrees. Do not assume. Okay, so I want to know, and I'm going to talk a little faster so this video isn't forever. You can also speed it up or slow it down. Pause, unpause, move forward. So I need to know what is the base and the height. The base and height are perpendicular. Here's the 90-degree angle. So this is one of those lines. That is the height. And the base has to be the entire side of this triangle, which is 8. Everything after that is calculator. Now, I never said what the units were. Centimeters, feet, miles. So it's just units if I don't know what it is. And when you're doing area, area is in square units because it's 8 units here times 4 units there, and anything times itself is squared. So this is units squared. That U is for units because I never said what I was measuring with. Okay, so if it was centimeters, it would be centimeters squared. So going on to the next one, you have to pick out which one's the base and the height. The base, remember, is always part of the triangle, and the height has to be a perpendicular line. So again, I should have put a box over here. My bad. So here's a box, so there's a 90-degree angle. So the base has to be part of the triangle. This is not part of the triangle. This one is, and it's still perpendicular to this. So you should always start with the formula. Some of you will be very tempted to skip that. Do not skip it. Base 3, height 5, and then we use the calculator. You get 7.5 units squared. The next question is not asking you for area, it's telling you the area. It gave you the shape of triangle, so you're going to write down the formula, get in the habit of writing the formula, 1/2 base times height. And then we're going to substitute. It said that the area was 50, so where it says area, I write 50. 1/2 is still a half. The base is 12. Remember when you substitute to use parentheses, the height we don't know, leave it H so we know what it is what we're looking for. Okay, so this one we're actually solving. The other ones we were evaluating. We were just putting it in the calculator and getting the answer. This one we have to get the H by itself. But I'm going to simplify first. 1/2 of 12 is 6. You can also use the calculator for that. And this is a one-step problem now. If I want to get H by itself, the coefficient has to go, and we divide off the coefficient. Do it to the left, do it to the right. Don't cause a fight. Drop it like it's hot, see what you got. Don't forget, if Simon doesn't say round, you're not rounding. So it's 8.3 repeating. And this is height, not area. So it's not units squared. It's just regular units. Okay. Here's another one it's giving you the area, and then it's asking you to solve. It doesn't say solve, but there isn't much else for you to do. So we got an area. It's a triangle. 1/2 base times height. Notice I'm not writing times because when letters are next to each other, it's implied. So do I know the area? Yes, I do. It's 77. 1/2 is 1/2. The base and the height have to be perpendicular to each other. The base is 14. The height is some randomness. Y plus 2, no big deal. We can handle that. So if you remember from the solving section, I didn't go through the checklist last time, but parentheses first. Do I have parentheses? I do, and I have this in parentheses also. Can I do 1/2 of 14? This is all multiplication. Times, times, times. Multiplication is commutative. I can change the order. So let's just simplify this. 1/2 of 14 is 7. And again, math is wonderful because there's more than one way to do it. So right now I'm just going to stick with my checklist. So I'm still doing the parentheses step. Parentheses means you distribute. So I'm going to draw the area model, the box underneath. Move this 7 here. 7 times y is, 7 times 2 is, and I'm going to rewrite the problem. So now this 7 was used. Do not rewrite it. It is turned into 7y, and it's turned into 14. Parentheses step is done. Is there any same side combining? Can I add these together? No. Are there any like terms on opposite sides? Yes. Or, so that's OSO, or I'm on the getting rid of plus minus step. So I'm trying to save Princess Y, so I'm going to get rid of this soldier out here, the opposite of plus 14. To both sides of this equation. Drop it like it's hot with everything I've got. 77 minus 14 is 63. Then I get rid of any multiplying or dividing. I have multiplication, and the inverse is division. The last step is almost always to divide by the coefficient. And now, is this units squared or units? It's part of a side. It's not an area, so it's just units, like centimeters or feet. Okay, now we're going to get into shaded region. Shaded region, I have that boxed in there. It says it's always area of the big thing minus area of the small thing. Okay, so the shape that's shaded is a triangle. I should just use my 1/2 base times height, except this base right here is not a straight vertical or horizontal line. You cannot just count the spaces to see how long that line is. And the height is also another diagonal one that you don't even see in here. So I don't know what the base and height are. But I do know that this is a rectangle, and I totally know how to get the area of that. And then I see 3 triangles on the outside, which are nice and easy right triangles where I do see and can count the base and the height. So our plan is to get the area of the shaded region is to do the area of the big shape, which is a rectangle, and subtract off triangles A, B, and C. I very conveniently labeled them because being organized always helps. So I want you to try this on your own. And if you noticed, I labeled the points for you. This is 2, 2, x is 2, y is 2. This is all in quadrant 1, so they're all positive numbers. This coordinate is 10, 4, right 10, up 4. This one's right 4, up 8. It's all in quadrant 1. So the first thing you want to do so we can get moving is let's label the sides. Okay, so what is we're going to do the rectangle first. This is where you're really going to need to pause the video. So I need the base and the height. Find the base and the height and then fill it in and write the answer for the rectangle. Should have got base and height of 8 and 6 and the area is 48. So the next thing we're going to do is we're going to do the triangles. I already wrote down the formulas because you always start with the formulas. So if I'm on triangle A, go ahead, write the formulas for triangle A. Fill in the numbers for triangle A, B, and C. Find the base and the height. Find the base and the height. If you mix up the base and the height, it's okay because multiplication is commutative. Okay, so go ahead, pause the video. Count the spaces. Count the spaces. Don't count the lines. So this side over here is 1, 2, 3, 4. And then fill these in and we'll see if we get all the same numbers. Okay, I got 1/2 of 6 times 4 is 12 for triangle A. 1/2 of 8 times 2 is 8 for triangle B. 1/2 of 2 times 6 is 6 for triangle C. And remember, it's the big shape, which is the rectangle. I like to draw my shapes around my numbers. Minus all those triangles, which 12 and 8 is 20. Plus the other one is 26. So when I take rectangles, subtract off the triangles, I get my final answer of 22. Okay, hardest problem on the page. Answer is 22. Now we're going to go to the other side, practice some other stuff. Here we go. Base and height are still perpendicular. Base is part of a parallelogram. The height doesn't have to be part of the parallelogram if the opposite sides in a parallelogram are equal. So you will see dashes like this for that. Like a 1 dash goes with another 1 dash. A 2 dash goes with another 2 dash. These arrows you see are the symbols that we draw when lines are parallel. Parallel lines have the same slope, they never cross. So a 1 arrow is parallel with a 1 arrow and a double arrow parallel with a side that says double arrow. So here we go. We got this example here. It's only 2 numbers in this one, so you really can't mess it up. Base is here. Height, it should have a box, is perpendicular, so 10 times 3 means that this area is 30. Remember, units squared, because it's this many units times that. Anything times itself is squared. Now we're going to go over to question 7. Question 7 has a lot of different numbers, so we just got to recognize which one's the base and the height. Base and height have to be perpendicular. Base is part of the picture. What's perpendicular to the 11? Perpendicular. That would be 4. Area. Formula first. Answer is 44 units squared. And then if you kind of cut these pictures up a little different, you can get a shape called the trapezoid. The trapezoid is the one that really starts to confuse people. But you can always, if you forget how to do a trapezoid, if you look at this, you can change it into a parallelogram with a triangle attached to the side. So you can, if you don't have to know this formula if you don't want to. You can always piece things together. A trapezoid's definition is a quadrilateral, which means 4 sides. One of these pairs is parallel. That's why you only see the arrows on one pair. And then the other sides are called the legs. The parallel sides have B's because they're called the bases. These bases aren't necessarily the same size, so that's why I call one B1 and the other one B2. These are not exponents, they're subscripts. They're just labels. They're just one way to name this so that I know that these bases are different. So here we go. We're going to use our formula, which sounds a lot like a triangle formula. So that's how I remember it. It's triangular-ish. So this is a triangular-ish formula. 1/2 bases times the height. Parallelogram, base times height. Triangle is half base times height. Trapezoids are triangle-ish, half bases times height. So I'm just going to go through these examples and then talk about the homework. So first you need to recognize what's this shape. This shape has one pair of parallel. It is a four sides, it's a trapezoid. So to do this quickly, I write a little trapezoid shape. 1/2 bases together times the height, which I actually already had written right there. So the bases, remember, the bases are the ones that are parallel. So I'm going to fill this in. The bases are the parallel ones, so that would be 8 and 6 together. And height has to be perpendicular, so there's my right angle. Here's my perpendicular side right there. Everything else just goes in the calculator. Now you could add this together yourself, but Mrs. Roberts always recommends if you can do it in the calculator, do it in the calculator. You don't have to add these. Put the whole thing in the calculator all at once with the plus, with the parentheses and everything. You don't even have to do this. So, and this is area. It is units times units, so I get units squared. Okay. Okay, looks like I got one pair parallel, four sides, trapezoid, formulas first. Bases are the parallel sides, so that would be which ones? That's right. The height has to make the right angle with it. Kind of don't have many choices on this. And the answer comes out to be 60 units squared. And then I put in another example just to make sure that you don't get confused if something's all turned around. This still has parallel sides. The parallel sides are the sides that never cross, so that would be the 8 and the 7. So we have the 8 and the 7 that are parallel, and the one that makes the right angle would be 4. So that would be the height, and then we put it in the calculator, and we're good to go. And we know the answer is 30 units squared. Okay, so again, I know this is a little longer, but this is 2 to 3 days of work. There are other videos to help you. Make sure you look out for those. And the homework is on the other pages. You see, I have the homework on this page, and there's all different shapes on here. So you want to make sure you recognize the shape before you do the formula. So like this one is a triangle. This one is a trapezoid. This one might involve shaded region. And this one's three-dimensional, but it's only asking you for area. So it's only asking you for one of the sides. So this side right here is a triangle. This side over here is a rectangle. What's great about these sheets is you find the answers on the bottom and you follow the directions and you get a little saying. And if you need help, you message me and you watch the other videos and take your time because you have time. Okay, have a nice day.